All right, we've now got part 7 wrapped up. So in the implementation plan overview, let's go ahead and come over here and mark it off. Moving on to part 8, in this section what we're going to do is get the bar class fully implemented, and then we're going to turn around and use that bar class in our cells class so that when cells begin to die, we can see exactly how much life the cell has remaining. Remember, when we showed you the cells transitioning between the green color and the purple color, it made it very challenging to find that particular cell, especially when there's a lot of them on the screen. It's like, oh, what cell's dying? And it's just really challenging, especially if you're slightly colorblind. But by having a life bar for the cell appear, it'll make it a lot easier for the player to quickly identify what cell is dying. So that is our plan. Let's go ahead and jump in here and bring up a fresh white screen and talk about how we're going to implement it. The first thing we're going to do is come up to the top, of course, and write out part 8. And I'm just going to call it life bars, so that we know we're talking about bars for our cells. Okay, this is going to be a very quick overview for the most part. The first thing that we're going to do is, well, actually, we're going to start out by fixing some spelling. Yeah, you guys let us get by with some spelling errors, well, an error, over inside of our bar class, which is the alignment. I believe we call the enumeration an alignment. So, I can't believe I didn't get any emails on that. You guys caught us on amount. Got all sorts of people saying, hey, this is how you spell amount. Well, thank you very much. But nothing on alignment. So, fix spelling. And I'm just so that we remember, because we actually use our implementation plans that we come up with here, we'll just write down enum. Next, we're actually going to make a slight change to the enumeration, where, if you guys recall, when we did the skeleton in of the entire precision game, when we created the enum inside of the bar class for alignment, we had values, what was it, left, centered, and right, and values 0, 1, and 3. And I'm going to show you why we had those values. It was kind of an eyeballing thing. It looked pretty good, and it was just off by a few pixels, but we decided to go ahead and get a little bit more serious. And that's the whole idea of doing these implementation plans, is as you're working through the development process, you're going to find things where it's like, hey, wait a minute. Looking at this on paper, I could do this, and it would be a little bit better. And that's exactly what happened when Logan and I were coming up with the implementation plan for life bars. So what we're going to do is we're going to change the enumeration just a little bit. And again, I'll explain why in full detail in a few minutes. That would be minutes. All right. So instead of it going 0, 1, 3, we're going to have it go 0, 1, 2, which means we'll just remove the numbers and let them be assigned by default. Okay. After we take care of those things, we're then going to implement the methods inside of the bar class. And there's not a lot of them. Now remember, the bar class really is all about representing a bar, like a progress bar on the screen. So in essence, the key thing is drawing. It's all about drawing. So what we need to do is implement a draw bars method, a draw method, and then go in there and finish off implementing our constructor, because right now I believe all we have is the bar being added into our static list of bars. So let's go ahead and take a look at these guys real quick and see what exactly we're going to do. We'll start out with draw bars.
In the withdraw bars, it will be very similar to the actor class, where the actor class had a draw actors method.
Exactly.
This method will be static, and it's used so that we don't have to loop individually outside of the bar class. Since all of the bars are auto-handled inside of that list, it's convenient to have a method that will go through and automatically loop to the bars and draw all of them. That makes the code back in the main game class more simplistic.
So basically, we're going to loop through all of the bars using a regular for statement, and then we'll do something like bars, and we'll use our index I, and then we'll call upon its draw, and we'll pass along sprite batch. Something like that. And that'll be it for draw bars, which means the meat of everything is going to exist inside of our draw method. So draw is going to look like this. We're going to start out by defining an origin. Now let's keep this in mind. When we are drawing sprites to our screen and we're using an origin with that particular draw overload for the draw method for sprite batch, that origin is going to control exactly where the icon or sprite is going to be drawn position-wise. So as we have seen, if we say the origin is in the center, and then we say draw 200 by 200, this becomes our 200 by 200. Okay? So since we have the ability to align these bars, left align, center, and right align, well, origin is going to play a key role in how the bar is going to get drawn. So basically, we're going to change out our texture. This goes back to this change enum that we had back here. Now, originally, what we had was a 3 by 3 texture.
If you'll remember, the file name was even called fill33.
That's right. Excuse me. And this was our texture that we were basically going to stretch out to make it represent our actual progress bar, the life bar. Okay? Well, here was the problem that we ran into, and this is what caused us to go back and change the enum. Using an origin set to 0 for left align said start from right here, draw from right there, and that worked out fantastic because it drew in that direction. So when we scaled it up, if you will, it went off to the right, or stretched it up if you want to look at it that way. If we said use center alignment, then that said use 1. So here's pixel 1. Basically, it meant we were going from right here. So what ended up happening is it would look centered for the most part.
It would be more centered. It just wouldn't be completely centered. It wouldn't be balanced.
It's right, because you'd have more. Hey, that's awful looking. You'd have more. Try that again. You'd have more on this side than you would on this side. So you get an effect like that. But it looked good, and we went with that. Then, if you wanted to do right align, remember we used 3. The reason we used 3 is because if we had used a value of 2 in our enum over here for right align, the problem was we basically had what looked like another center, except for now it was mirrored from the center that we were using, meaning that we would get more on this side, but we would still get some stretching on this side.
Really what it came down to is when I was testing this out, I used bars that were too narrow, and I couldn't tell which side that they were aligning on. So what it looked like to me is that 1 and 2 were both center aligning for some reason.
Exactly.
And then you had to go all the way to 3 to get it to right align.
But it looked fine, so it was like, hey, okay, that works, let's move on. So if you use 3 from right here, well, it is right aligned because now everything's going to go that way.
Right, everything is now at the left of the origin. So if you begin to stretch the texture, you stretch to the left instead of centered or to the right.
So what we're going to do is change this over to a 2 by 2. And so with a 2 by 2, check this out. Now, if our enumeration says we're going to do a left alignment, and a left is 0, or contains a value of 0, well, that's going to work nicely. So there's left. If we say 1, this is where 1 is, and guess what? Nice, equal stretching in both directions. So it does look like we are center aligned.
An origin of 1 would give us an equal number of pixels to the left and right of that origin. So if we were to scale, we'll scale evenly.
That's right. And then finally, if we said use a value of 2, we're over here. And we are indeed right aligned because we're going to stretch in that direction there. Looks like that's going to work out great. So we're going to replace our fill 3 by 3 graphic with a fill 2 by 2 graphic, and we're going to change our enumeration, and then everything is going to work perfect. So very few changes, but like I said, as we go through these implementation plans and really start planning things out in detail, things like this creep up. I mean, it happens in the real world. And what do? Well, you make changes to accommodate for what you need to have happen. And in this case, we decided we wanted to go ahead and make it dead on perfect. There was no reason not to. So that will fix things for us. So now inside of draw, how are we going to use this origin? Because like I said, it's all about the origin for where the bar gets drawn. And then as we stretch this bar, it's going to stretch from that point. So once again, is it going to be left Let me just pull this up easier to see. Is it going to be left? Is it going to be centered? Or is it going to be right aligned? So inside of draw, the first thing we'll do is we will create a vector 2 that is called origin. And with it, we're just going to create a new vector 2. And then inside this vector 2, so now we need to go ahead and designate our our X and our Y. Well, and these are both floats. So since we're going to be using the alignment, which is going to handle basically that enumeration, whatever we've set it to from our defined enum, inside here we'll just cast over to a float.
Right, if you remember back to the lesson over enum, we actually played around with this, using the enum value directly when showing it,
right,
and then casting to an int before showing it. Though what we're going to do here is cast to a float, since that is the type required. So we're going to cast directly to the required type.
And so there you go. So this right here is going to represent our X, or our left and right, where this is going to represent our Y up and down, and as you can see, 0, 0 is fine. So with our graphic up in the corner. Okay?
Right, so we're never going to handle centering on Y, but that's because bars have thus far been designed to be a very thin horizontal bar.
That's right.
So we're always going to draw from the very top of that bar. There's going to be no mechanism for centering in Y, but generally we're putting bars either below things or positioned at a pixel location on screen, so it's very easy to determine where they're going to go in that case.
So now with an origin that we can use in the draw method for sprite batch, now what we need to do is turn around and define a destination rectangle. So where do we want to draw this to? And this is going to handle our stretching here. So we'll just define a rectangle outside of the draw method to keep everything nice and clean and easy to see. So let's do it real quick.
And what's funny is if you look back through the fields that are available inside a bar, we have things like a position, a width, and a height. And those alone could define a rectangle. As a matter of fact, if those are used directly, they'll define a rectangle for the bar at 100% width, or rather a bar percent of 1.
Right. But we obviously need to be able to control that.
So the key here is that percent is supposed to control it. So if we include percent when calculating the width, then we'll end up with a final rectangle that will grow and shrink with the actual percentage. So if we make a rectangle, that's exactly what we're going to do, is to assemble a rectangle out of the position, the width, and the height. Now position is given in a vector 2 to allow screen positioning to be done very easily. The only trick here is that the rectangle has an X and Y given an int, so we have to cast the position over to an integer to store it in a rectangle. And then here's
the meat of it right here.
the final components of the rectangle, of course, width and height. And width is going to be the part driven by percent. And really it is as simple as multiplying width by percent. Since if we multiply by 1, we get the full width. If percent becomes anything less than 1, then we'll start to shrink in width. You'll notice that we had to cast out calculation over to int as well, because percent is a float. So multiplying the float by the int is going to have a float result, and that float result has to be casted before it can be stored in a rectangle, whereas height, the integer field, can be stored directly.
Exactly. So here we are. If we said start at a particular position and we were left aligned, and our width happened to come in with a value of, let's say, 20 pixels, and the percent was at 1, so we were 100%, we would be drawn from left aligned from the top, so like such, 20 pixels out by whatever height we had defined. There is our full bar. But if percent happened to come in at 0.5, so we're now 50%, well, what's going to happen? Well, now we have width, 20, times 0.5, so we're going to end up with only 10 as our rectangle for our draw area. And of course, drawing from up here in the corner. Okay? And again, the origin becomes so important, this whole lecture about what's taking place right here for the alignments, because if we were actually drawing, let's say we were right aligned, then it would look like this. Same position, right? Except we're going to draw in this direction. So we would have, let me see if I can clean that up a little bit, 10 going out over here.
What's actually interesting about the way origin is applied is that it is applied in the space of the source texture, because you'll note that even if we had a bar of 20 or a bar of 10, we still have an origin that is either 0, 1, or 2.
Mm-hmm.
We don't adjust the origin for how wide the destination is, we adjust the origin for how wide the source is. But once we have that origin applied, it gets stretched to the final destination, meaning if the origin is telling the texture to stretch out to the left instead of to the right, it still stretches by the destination, not by the source.
Right.
So the origin comes from the source, but is applied to the destination.
Exactly. And now with this, we can just simply turn around inside of our draw method and do a sprite batch. That's an R. Dot draw. And then we can tell it things like we've got our static bar texture. We now have our destination rectangle, so we have this bar rect that we just defined above. Right there. And then we can keep on. We're not pulling from any source rectangle, so we can just set that to null. And then we've got our color, and there'll be no rotation. And we'll use the origin. Once again, just defined a second ago, so we know where are we going to be drawing from. And then I'm just going to, this is pseudocoding here, none for our sprite effects, and layer, put it 0. Okay, so we can send all this off to draw, and boom, there's our bar drawn to the proper percentage at the right location based off of its alignment. Okay, so that would take care of the draw implementation. So from there, all that would be left would be to go into our constructor and finish off the implementation there.
And most, if not all of that, is just going to be initializing fields.
It will be, such as this dot width equals the width that just came in, the height is equal to the height that just came in, the color is equal to the color that just came in, and then a couple other things that we'll need to do, and I'll jot these down because this is a little more important, is we'll need to do something like this dot percent. As we've got that percent field, we need to make sure that when we create a new bar, that it automatically gets initialized to a value of 1. So the bar comes into existence with full life. So we need to make sure that that is in the constructor. And then we'll also go ahead and just explicitly set the alignment as well. We can go ahead and like left align it or something. So in the constructor, we'll take care of all of this initialization stuff, and all will be good. And that will wrap up the implementation of the bar class. And then we're going to move our attention away from there. Actually, let me undo that. And where's that shift button at? So much better. As you guys can see, I've been working on my lines while away from video recording. Okay, so the next thing we're going to need to do over inside of our game class in the load graphics content is load in the static texture, the bar.texture that we just talked about a second ago.
Right. Looking back at spritebatch.draw, we noted the bar.texture. That's a static field held in the bar class, but that has to get initialized somewhere. So what we're going to do is go back to the game class and set that bar texture field from load graphics content at pretty much the same time as where we're loading all the other textures.
Right. So I'll just jot down as a note, game class, load graphics. Go ahead.
And yeah, I was just about to say load graphics content, but that's and that's it.
Don't you love how I jump back and forth, uppercase, lowercase? Let's mix the two, keep the party going.
No, my favorite is everything's uppercase, but the capital letters are just bigger.
Well, thank you. I'm glad you noticed. All right, from there, what we're going to do next is jump down to the draw method inside of the game class. And make a very simple call to our bar.draw. Well, let me just jot it down. We're going to call the bar draw bars method. Excuse me.
So that way, it just tells bar to draw everything, draw all bars that it is currently controlling, and that way we're left with one simple call inside of the draw method in the game class, and then bar handles it from there in order to properly loop through all existing bars and call the individual draw methods of each bar. Exactly.
Now, order is very important because right now we've not got into layering our sprites with a sprite batch. And that's something we're going to be talking about a little bit later on in the XNA Xtreme class. So where we call this bar.drawBars is very important. Do we want the enemy to be above the cell but below the bars? So that would happen if we put this call to draw bars after the other two draws for the enemy and for the cells. So we need to keep that in mind when we're choosing where we want to call draw bars at, such that enemies is going to be called, the enemy's draw will be called after our cells and our bars. Okay? So let me go ahead and just draw another line in here because that will wrap up our work that needs to be done over inside of our game class. So then the rest of everything is over in the cell class. Because now that we've got bars that we can use, we need to use them. So there's just a handful of fields that we need to put in place in the cell class. These fields are all bar related. Things like the default life bar height, which will be a constant. Let me just jot some of these down as notes.
Right. This final section we're dealing with the cell class is really could be viewed as an upgrade to the existing cell class to include life bars for each cell.
Like we'll set that to 8. And then we'll have a color for the life bar color.
And this is almost like a miniaturized version of the game parameters that are held in the game class. These are bar parameters held in the cell class to describe the cell's own life bar.
Exactly. And then, so we'll have a red life bar for all of our cells. And then, obviously, the most important, and I'll go ahead and actually write the type out here, we need to define a variable that's going to hold the bar itself. So we'll have bar, and we'll call it life bar.
So we have the things to describe the life bar, and of course the reference itself to that life bar.
And then after that, just a few things that we need to create, or add to, inside of some of the methods, such as in set attacked.
Right, once we have these fields, from here on out it's just usage. What needs to be added to the code in order to make the cells have life bars? Because they don't have life bars when they first begin. When the level begins, they don't have life bars because they're not attacked.
That's right.
So that means once we get to set attacked, that's the point at which we actually create the life bar for a cell.
And then in update?
Well, the life bar needs to shrink along with the life. The life gets decremented inside of update, so we can put this alongside the life percent calculation inside of the cell's update. So somebody take life bars and make sure that they decrease over time as the cell dies.
And then finally, as this is going to go in a couple of places, we need to remove the life bar.
Right, since the life bar is actually a separate entity. Life bars can exist without cells. That means we need to make sure that the life bars get removed after the cells die or are, you're just about to get to those.
As they are rather saved or when they have died.
Right, both of those cases, because you wouldn't want to have a scenario where a cell is dying, so it has a visible life bar, you save it, and now the bar remains.
Exactly.
That would be a lack of cleanup on the part of the bars.
And with that, we should have fully functioning life bars for the cells. So the biggest thing coming into this implementation plan, some spelling cleanup at the very beginning. We're going to change our enumeration. Hopefully we've made it pretty clear as to why originally we went with the enumeration for left, center, and right being 0, 1, and 3 because we were using a 3x3 graphic. But as I had demonstrated up here, this caused trouble with us. Again, it wasn't something that was really a thorn in our side with our current implementation of precision, the one that we showed to begin with, for the simple fact that, having 1 being right here, it looked fairly centered.
Well, we even showed the game. No one noticed it.
No one noticed it. It looked fairly good. And we never used right align, so we weren't worried about that. And by setting right align to a value of 3, it was perfect anyways.
Right, and that was what was funny is left and right align were actually working correctly.
Yep.
It was center align that was broken.
That's right. So we just changed it over to this 2x2, loading in a new graphic in this section here, and then we'll change the enum, and all of that's going to work out beautifully the way intended to begin with. And then we'll just implement the methods, get draw bars in place, get draw in place, and then finish off that constructor. Then jump over into our game class and get the texture loaded in that we're going to need to use, and then turn around and make our call in the draw method to draw bars over inside of bar. And then we'll move over to the cell class and get everything implemented so that we actually have life bars being created for cells that are attacked, and then making sure we clean up when a cell is saved or dead or died by removing that life bar out. And that is the objective for Part 8. And this here is our implementation plan. So with that, Logan, let's go ahead and get busy coding this all up. Thanks a lot, guys.